Okay, so ready, we start to discuss this exercise. Okay, we start to discuss this exercise. Okay, so this one, the first one is very simple lah. Okay, very simple. Okay, 70 Newton, 90 Newton. Okay, Sammy and Hengi pull a crate with forces of 70 Newton and 90 Newton respectively. So find the resultant force on the crate due to these two forces by drawing scale diagram. Okay, A, drawing scale diagram, B, through calculation. That means you have to show two versions of answer. The first version is where you show how you get the answer by drawing scale diagram, and then the second one is you do by calculation. Okay, so if you do by showing the scale diagram, okay, I show you, okay, the scale diagram. Okay, so first, it says that okay, so it is 70 Newton and 90 Newton, and it doesn't give us although it asks us to draw the scale diagram, but doesn't give us the scale. So that means we have to decide on the scale ourselves. Okay, so the most simple way to set the scale is that we try to put 1 centimeter equal to 1 Newton. That is the most simple scale. But you see the force is very big, 70 Newton and 90 Newton. So you can set 1 centimeter to 10 Newton. Okay, 1 centimeter to 10 Newton. And another thing to consider when you want to choose a scale is that you need to choose a scale that is as big as possible. Okay, what I mean is you choose a scale where it will make your diagram to be as big as possible, because the larger the diagram, the more accurate it will be. Okay, remember, the bigger the diagram, the more accurate the answer. Okay, the greater the accuracy. Okay, so for this one we choose 1 centimeter to 10 Newton lah. Okay, 1 centimeter to 10 Newton. Okay, so we draw one line. And then we measure. Okay, we measure 9 centimeter. Okay, we measure 9 centimeter. Okay, 9 centimeter. So this is the 90 Newton. Okay, after that we use protractor and we measure 90 degree. We use protractor, measure 90 degree. Okay, 90 degree is here. And here also we measure 90 degree. Alright. then we draw straight line up. Here also straight up. Okay. Okay, and then this side, this is 7 centimeter. Okay, measure 7 centimeter. Okay, here and here also. Okay, so this one will be, okay, so this will be 70 Newton. Here is 70 Newton. Okay, and then we draw line to join. Okay, like that. So this one is also 90 Newton. So make sure you got label the arrow. Okay, make sure you label the arrow. Okay, so this is 90 degree, 90 degree. Okay, and then after that we draw a diagonal line. Okay, we draw diagonal line from here to here. Why? Why we draw the diagonal line from here to here? Why not from here to here? Okay, why not here to here? Why here to here? The reason is because you look at the force, pull this direction. So logically, the object will move in this direction, right? So that is why the diagonal line or the direction of the resultant force will be in this direction. Okay? So, we measure the length of this diagonal line, and for me I get okay, I get 11. Okay, the length is I get 11.4 centimeter. So because 1 centimeter represents 10 Newton, so that means the resultant force will be 11.4 times 10 Newton. So okay, times 10 Newton, so we will get 114 Newton. And then we measure this angle is how much by using the protractor. And we get 39. Okay, for me I get 39. Alright. Okay, 39 degree. Okay, so the answer will be 114 Newton to the direction of 39 degree from the 90 Newton force. Okay, so this is the answer for the A. That means by drawing ray diagram. Okay, so next is we want to do B. Okay, this is complete answer like this. If question asks you to draw ray diagram to find out, then this is the way. Okay, this is the way you show your diagram, you label everything complete, and then you must show how you get the answer. Okay, how you get, and the direction, everything must be complete in order to get the full marks. Okay, so this is actually not difficult. This is actually not difficult. This is actually easy. So please make sure that you know how to draw properly. Okay, and if question come out and ask you to draw, usually the mark will be like 3 marks. So 3 marks is actually quite a lot. Okay, so please don't waste lah. So B, they want you to calculate. So if calculate, because this is perpendicular, so that means you can calculate by using Pythagoras theorem. So the resultant force will be 90 square plus 70 square, whole thing square root. So you get okay, you also get 114.0 Newton lah. Okay, so now for the direction, you can calculate by using tangent. Okay, tangent theta equals to 70 over 90. So equals to okay, so this is 37.9 degree. Okay, 37.9 degrees. So that means just now I get 39 degrees. Actually not very accurate lah. Okay, not very accurate, but still within the range lah. Because if the actual answer is 37.9, that means I should get, if I am accurate, I should get 38 lah. So the marking scheme is usually plus minus 1. Okay, plus 1 degree minus 1 degree. So 39 is still within the range lah. So still within the acceptable range. Okay, so if you can get 39 or 37, 38, 39, then it's okay. Alright, just not too far out lah. Okay. Okay, so after you get from calculation, then you must combine with this answer. Combine together. You cannot show the answer separately. Okay, so you must say that this one symbol represent the resultant force. So you must say that the resultant force equal to 114.0 Newton to the direction of 37.9 degree from the 90 Newton force. Okay, complete answer like this. Understand? Okay, you cannot show the angle separate from the resultant force how many Newton. You calculate at the side and then you combine inside the final answer. Okay, now we look at question number 2. Okay, question number 2, this one. Okay, you look at this. Okay, you look at this number 2. Okay, so we have a 10 Newton force push in this direction and 125 Newton force pull downward. So logically, what is the direction of this object? Logically, the direction should be this direction, right? Okay, the object should move in this direction because we pushing 10 Newton is actually the same like if you have a force of 10 Newton here. So that means this is actually the same like one object, you have 25 Newton here and you have 10 Newton here. So the object will go in this direction. Okay, so if like this, how to let's say if you want to find the answer by using ray diagram, If you want to find the answer by using scale diagram, you want to draw scale diagram. So how to do it? By the way, in this question, you look at this question, it doesn't say what method to use. It just say find the resultant force. So that means you have two choices. One choice you draw, another choice you straight away calculate, no need to draw. Okay, so let's say you draw. Okay, let's say that you draw. Okay, so if you draw, first thing of course you have to choose a suitable scale. Okay, you have to choose a suitable scale. The scale that you choose must be so that your diagram, your scale diagram is quite big. Okay, not too small. Understand? Okay, if too small, then it's no good. The accuracy is low. So what is it that is suitable is you can choose 1 centimeter to 2 Newton. Okay, because if 1 centimeter 2 Newton, then this one it will be 5 centimeter. This one will be 14 12.5. Okay, for 12.5 Newton. Sorry, 12.5 centimeter. Okay, so this one will be 12.5 centimeter. This one will be 5 centimeter. Okay, so 12.5 centimeter is okay lah. Okay, you can draw with a 15 centimeter ruler you can draw. But my advice is you go and buy a ruler that is 20 centimeter. Okay, my advice is you buy 20 centimeter ruler. Okay, go to bookstore, buy ruler that is 20 centimeter long. Okay, why 20 centimeter? Because 20 centimeter first is not too long, not too short. 30 centimeter ruler is too long, so not convenient to bring around. Okay, you cannot put 30 centimeter ruler in your pencil box. But if 20 centimeter ruler, most pencil box I think can fit lah. Okay, I think can fit. And you don't buy the hard one lah. You buy the one where the ruler is soft. Okay, 20 centimeter long, soft ruler. Okay, and then you can put inside your pencil box and you can carry around, so it's convenient. And 20 centimeter ruler, not only you can use to draw scale diagram, but also more suitable for you to draw graph. Okay, because graph, when you want to draw the axis, you want to draw the line, you need a long ruler. Okay, like what I say, 30 centimeter you feel maybe too long, difficult to bring around. So if 20 centimeter is just nice. Okay, alright. So I recommend buy 20 centimeter long ruler. Okay, now so what will be the scale diagram for this one look like? So you have 10 Newton here, and then you have 25 Newton here. Okay, 90 degree. So the object will go in this direction. So that means the parallelogram that you draw, it should be like this. Okay, this one is 25 Newton, this one is 10 Newton. Okay, you see or not? Okay, and then the angle, the direction, you can get this one. If you don't want this one, you can also do this one. Okay, from 25 Newton also can, or from 10 Newton also can. Okay, so now we draw the actual one. Okay, so first, okay, so 5 centimeter. Okay, 5 centimeter. Okay, and then 12.5 centimeter. Okay, measure 90 degrees. Okay, you have to measure 90 degree and then you draw the 12. Okay, 12.5 centimeter. Okay, so measure 12.5 centimeter should be here. Okay, so connect here to here. Alright, so 90 degree. Okay, so this one, the direction of the force is like this. So this is 25 Newton. This is 25 Newton. 25 Newton. 20, sorry. This is 10 Newton. Okay, 10 Newton. 10 Newton. Okay, like this. So the direction of the force of the resultant force should be here. Okay, like that. Okay, the resultant force. So the angle is over here. So let's measure how long is this diagonal line. Okay, I can get 13.5. Okay, so 13.5 centimeter. So that means the resultant force is 13.5 times 2 Newton. Okay, so that means it will be 27. Okay, 27 Newton. So the direction (69). Okay, 69 degree. Okay, so 27 Newton to the direction of 69 degree from 10 Newton force. Okay, like that. So this is the answer lah. Okay, so this is the resultant force. 27 Newton to the direction of 69 degree from 10 Newton force. Okay, so another version is if you don't draw, you straight away do calculation. Remember, this question, it doesn't tell you which type of way to show the answer. Okay, how to do. It doesn't say okay must draw. It doesn't say calculate. Okay, it just asks you to find. So you can use whatever method. So if you want to calculate, so the resultant force will be 10 square plus 25 square. Okay, so we get 26.9 Newton. Okay, and the direction tangent theta equals 25 over 10. Okay, so equals to 68.2 degree. So 26.9 Newton to the direction of 68.2 degree from 10 Newton force. Okay, like that. Okay, get the idea. Okay, so this is how you show. Okay, this is how you show your answer. Alright, so let's. Okay, any question? Anybody have any question? Okay, so if no question, we go to the next one. Okay, the next one is we want to find the resultant force for the ocean liner. Okay, so for this one, the question already give us 1 centimeter to 1 kilonewton. Okay, although it say find the resultant force, but the question got give us the scale. That means what it's trying to tell us is you must draw. Okay, understand? You must draw. Okay, and if the question say calculate the resultant force, then you have to calculate lah. But if the question asks you to draw, you must draw. If the question doesn't say to draw, doesn't give you any information for you to draw, then if you want to draw also can, you want to calculate also can. Okay, all right. So for this one, must draw. Okay, because God give you the skill. Okay, God give you the skill. Okay, so 10 kilonewton, 12 kilonewton, the angle in between is 68. So let's draw a rough one first so that we have an idea what will be our diagram will look like. Okay, so like this here and another one here. Okay, so our diagram should look like this Okay, this one is 10 kilonewton. This one is 68 degree. This one is 12 kilonewton. Okay, 12 kilonewton. This one 10 kilonewton. Alright. Okay, so that means the resultant force will be in between like this. Okay. Alright, so let's draw. Okay, so 10 centimeter. So 10 centimeter is here to here. Okay, so this is 10 kilonewton. And then you have to measure 68 degree. Okay, 68. Here also 68. Okay, so okay, measure 12 centimeter for 12 kilonewton. Okay, here and over here. Okay. and then join together. Okay, so this one is 10 kilonewton. This one is 12 kilonewton. This one is 12 kilonewton. This is 68 degree. Okay, so the resultant force is here to here. And the angle that we want is here. Okay, so let's measure. So this one we can get 18.2. Okay, 18.2 centimeter, and the angle .38. Alright, so the resultant force will be okay, so 18.2 centimeters, so 18.2 times 1 kilonewton, so that means it will be 18.2 kilonewton to the direction of 38 degrees from the 10 kilonewton force. Okay, so this is the answer. Alright, next. If you have any question, please please ask. Okay, if you have any question, please ask. Okay. Okay, so the next one. Okay, use your logic. 9 Newton pull here, 5 Newton push here. So logically, this object will go somewhere here lah. Right? The reason is because 5 Newton push is the same like 5 Newton pull. Same like this. So that means this is the same as 9 Newton, 5 Newton. So the resultant force will be somewhere here. And the ray diagram should look like this. A ray diagram, the scale diagram should look like this. Okay, 9 Newton, this one 5 Newton. Okay, so the angle you can get from this one. Okay, this one the angle, the direction. Okay, alright. Okay, so let's draw. Okay, so this question again, it doesn't give us the scale. Okay, this is another question that doesn't give us the scale. So you can choose your own scale. So the easiest is 1 centimeter represent 1 Newton. Okay, so this one will be 9 centimeter. This one will be 5 centimeter. Okay. So first we draw 9 centimeter. Okay, 9 centimeter. So this is 9 Newton. And then You see, okay, the angle here is 60 degree. Okay, here is 60 degree. So what will be the angle here? Okay, here it will be 120 degree right now. Okay, because straight line 180. So this one 60. So over here will be 120. So that means you must draw this one 120 degree lah. Okay, so measure 120 degree. Here, okay. So here also measure 120 degree. Okay, so this should be 5 centimeter. Measure 5 centimeter. Okay, join together. Okay, so this one is also 9 Newton. This is 5 Newton, 5 Newton. Okay, parallelogram. So here to here, this is 120 degree. Okay. All right. So the diagonal line is here to here. All right. So let's measure. This line is how long? So I get 7.7 7.8 okay. I get 7.8 centimeter. Okay, and the angle here is 34. Okay, so the resultant force will be 7.8 Newton to the direction of 34 degree from the 9 Newton force. Okay. Okay, John pushes a 12 kilogram carton with a force of 50 Newton. Okay, if the carton moves with acceleration of 2 meter per second, what is the frictional force acting on the carton? Okay, so you look at this question. Okay, so you see what are the two forces here? The two forces is this one 50 Newton and the frictional force. Okay, so if we want to find one way we want to find the frictional force is we can do like this. Okay, you see start from the equation of force equals to mass times acceleration. So what will be the total force here? Okay. Okay. One more time. Okay. Force equals to mass times acceleration. So what do this equation tell us? This equation tells us that this force act on this mass will have this acceleration. So what are the forces that is acting on the object? Okay, that means the mass, the 12 kilogram carton. So the forces that act on this is got two lah. This one the 50 Newton, and this one the frictional force. The frictional force is in the opposite direction. Okay, it's in the opposite direction. But here we just straight away write friction lah. Okay, force, friction. Okay. Okay, so this is the friction. Okay, so the mass will be 12 kilogram. And then what will be the acceleration? The acceleration, it tells us that is 2 meter per second per second. Okay, so that means these two force act on this 12 kilogram. This 12 kilogram will have 2 meter per second acceleration. So we want to calculate the friction. So it will be negative 26 Newton. Okay, you see it's negative 26 Newton. So you see the friction. Okay, the word friction already means that okay, wait, first thing you see friction is in negative 26 Newton because it is in the opposite direction. Okay, because it is in the opposite direction, so it is negative 26 Newton. But the word friction, the name friction itself already mean in the opposite direction. Same like the word deceleration. Okay, previously, if you still remember, in Form 4, we got learned about acceleration, deceleration. So the word deceleration already mean negative acceleration. So the value of the deceleration, you don't need to put negative. Okay, so here is also the same thing. So the friction is equal to 26 Newton. Okay, the friction equals to 26 Newton. Alright. Okay, so this is the frictional force that act on the carton. Alright. Okay, number 2. A shopper pushes a trolley with a force of 20 Newton. The trolley with a mass of 5 kg move at uniform velocity 1 meter per second. Okay. He then increases his force to accelerate the trolley. What force should he apply in order to give the trolley an acceleration of 2 meter per second per second? Okay, so this question sounds like very confusing. So when you face with this kind of question, one strategy that you can take is to draw the situation. Okay, you draw the situation. So by drawing the situation, you can make yourself easier to understand. Okay, easier to understand what is going on. Okay, so a shopper push trolley with force of 20 Newton. So let's say this is a trolley. Push with 20 Newton. So the trolley has a mass of 5 kg, and this 5 kg move with the velocity of 1 meter per second. Okay, uniform velocity 1 meter per second. Okay, what does this tell us? What do this situation tell us? What is it that we can learn from this is that, you see, this is uniform velocity. in what kind of situation do we have uniform velocity? Okay, if you look at this, the forward thrust is balanced by the drag and the weight is balanced by the lift force. So the plane did not move up or down and continue to move forward in constant velocity. So when is it that is constant velocity? When the forces are balanced, forward forces and the force to the back. Force in front, force to the back is balanced. Then you will have uniform velocity. Okay, same like here. Okay, we look back here, effect of resultant force. Okay, when two equal but opposite forces act on object, the resultant force will be 0. Okay, if the object is stationary, it will remain stationary because the two forces cancel each other. So it will be like no forces are acting on the 2 kilograms. So if the object is stationary, it will continue to be stationary. No change to the motion. This one, the object is already moving at 2 meters per second. Okay, the object is already moving at 2 meters per second. And then we have 5 Newton to the right, 5 Newton to the left. So these 2 5 Newton, they cancel each other off. Okay, so the resultant force is 0. So the object will continue to move at its original constant velocity. So that means it will continue to move with uniform velocity of 2 meters per second. It's not going to change because you don't have force. The 5 Newton already cancel each other off. So that means resultant force is 0. So that means the 0 resultant, there is no force that can make the object change the motion. Okay? So if we look back at this question, you see that it says that push with 20 Newton and the 5 kilogram trolley is moving with 1 meter per second, uniform velocity. This tells us that there is a opposite force of 20 Newton. Okay, there is an opposite force of 20 Newton, and this opposite force of 20 Newton, most probably, okay, we can take it as friction. Okay, we can take it as friction. Okay. Alright, so you see, this question, it doesn't straight away tell you that there's a friction of 20 Newton. The way that they tell you is by turn one whole circle, just to tell you that the friction is 20 Newton. Okay? The way that they tell you is that when pushed with 20 Newton, the object moves with uniform velocity. So if you understand about resultant force, okay, you see the situation. Oh, uniform velocity. If uniform velocity, that means the resultant force must be 0. But there is a 20 Newton pushing. How is it that the resultant force can be 0? The only reason is there is an opposite force of 20 Newton acting on the object, and that opposite force must be the friction. Okay? Alright. So he says that he then increased his force to accelerate the trolley. So what force should he apply in order to give the trolley an acceleration of 2 meters per second? So that means now he want to make this trolley have acceleration of 2 meters per second. So that means how much is the force that he need to apply? Then only can accelerate 2 meters per second. So that means now the situation become, we don't know how much is the force, but now we know that the friction is 20 Newton. Okay, from the first situation just now, we know that the friction is 20 Newton. Then we can use that information 20 Newton in this second part of the question. Okay? So, F equals to MA. This force act on this mass have this acceleration. So what are the forces that is acting on this 5 kg and make this 5 kg to have acceleration of 2 meters per second? This force and this friction. So F plus friction in opposite direction, so negative 20. Okay, so these two forces act on the mass. So the mass is 5 kg, the acceleration is 2. So how much will be the force that he need to apply? Okay, so it should be 30 Newton. Okay, should be 30 Newton. So that means when you apply 30 Newton, 20 Newton from the 30, 20 will cancel off the friction. So you have extra 10 Newton that can give the 5 kg acceleration of 2 meters per second. Okay, get the idea? You understand? Okay, problem involving resultant force, mass and acceleration of an object. Okay, so the situation is in the lift or elevator. Okay, everybody, you got take lift before lah, right? Okay, so in the following situation in the lift, calculate the reading of the weighing machine when a girl of mass 50 kg is on it. Okay, now reading on the scale show the normal reaction force. Okay, the reading on the scale is the normal reaction force. Okay, this is very important. W is the weight of the girl. So to calculate the weight, take the mass times the gravitational acceleration downward. And R is the normal reaction force exerted on the girl by the platform of the scale. Okay, because the girl stand on the scale, so the scale push back with a normal reaction force. Okay, so we want to see the reading. We want to calculate the reading of the weighing machine. Okay, and the mass of the girl is 50 kg. So let's look at the first situation. The first situation is stationary. Okay, so when it's stationary, what would be the reading? Remember, the reading is the same as the normal reaction force. So that means if we calculate the normal reaction force, then we can get the reading lah. Okay, so F equals to ma. If stationary, that means the acceleration is 0. Okay. So that means what are the forces that act on the girl? Okay, what are the forces? Two forces. One is the weight, another one is the reaction. Okay, so the mass of the girl is, okay, this is the mass of the girl and this is the acceleration. Okay, now, so what is the weight of the girl? The weight is mass times gravitational acceleration. Okay, this reaction is the one that we are looking for. We want to look for this reaction. Okay, so this mass is 50, gravitational acceleration. Okay, G is 9.81 meter per second. Okay, so this is negative because gravitational acceleration is going downward. So 9.81 plus R equal to mass of the girl is 50, acceleration is 0. So that means the normal reaction is, okay, the normal reaction will be 490.5. Okay, 490.5 Newton. Okay, upwards. So meaning this reaction force is the same as the weight. You see the weight of the girl. Okay, we will get 490.5 Newton. So when the lift is stationary, that means the girl is also stationary, not moving. So that means the force that is downward is equal to the force that is upward. The force that is downward is the weight. Downward, because the weight is gravitational force. Okay, weight is gravitational force. So the weight and the reaction upward, downward and upward is the same. So resultant force is 0. Okay, resultant force 0. So the girl also has 0 acceleration. Okay, you see or not? So the weight 490.5, the reaction also 490.5. So that means the reading of the weighing machine will be the same as the weight, will be equal to the weight of the girl. Okay? Okay, so we stop here lah, okay, for today.